Hello, and welcome to the Leap Trainer tutorial. After compiling the source code, you will want to run the program from the Leap Motion Gesture Training executable found within the build folder. The first screen you will see will be the trainer form. This form will allow you to record and train gestures. For the purpose of this demonstration, A, L, and Y have been pre-recorded. Let's train the letter B. Set the timeout and desired file count. I like to record at 20 frames per second, and I find 300 frames provides a decent amount of training data while keeping the storage costs down. After recording, I like to check how some of the frames look before I train. To train, simply hit the training button and make your selection from the list. After processing, hit the reload button to update the list. As you can see, each frame now has a new file associated to its number. These angles are used for the classification. The next form you will want to navigate to is the testing form. Do this from the drop-down menu. Hit the test button to activate the Leap Motion controller. When you're ready, perform a gesture and hit capture. You will then be able to see an advanced view of what you captured to determine if you need to make adjustments to the trained data. When you're finished, you can delete the data. The next form is the interpretation form. The Leap Motion controller will be active the moment you arrive. Simply perform any of the gestures you have recorded and trained. The Leap Trainer will attempt to classify and provide the name of the gesture. The gesture with the lowest fail count will be the name the program outputs. ASL isn't all the Leap Trainer can be used for. You can add your own custom gesture names. You can also delete gestures from the list. Thank you for watching.
Hello, my name is Hamilton Chavez. I am part of the AR-VR-VE for Computer Science team. My project, as I like to call it, ARCSE, ARCSE, is to design a set of learning activities using augmented reality. The primary actor of the project is the student, under the assumption that he or she has set up the webcam and the tracker. We can begin. This is the Learning Activity Selection menu. From here, the student will be able to select which activity they would like to perform. Let us now view the binary game activity. The user has the option selecting the difficulty level and an answer data pool of decimal or hexadecimal values. Upon confirming, a new scene launches. And then I will press OK. Now the student will select answers based on the questions that they are answering by interacting with the virtual buttons on the tracker.
Hi, this video is the user guide for CircGR. As previously mentioned in the installation video, after you have actually cloned the repo, what you want to do is find the solution file for Visual Studio. So first of all, you want to navigate to that particular folder where you clone the repo to in your local directory, and actually select, for instance, we'll start off with the CircGR API standalone. We'll open the solution for that. And the main thing here that I want to explain is the test file that is all the way at the bottom within the source files. This file is a way for you to quickly test the API once it's actually set up and opened correctly in Visual Studio, so that you can actually test to see whether the gestures are being recognized as they should. So if we run this, you'll notice that you're going to get a lot of output to the console. What is basically happening in the first few seconds is that you're uploading, parsing, using the gesture parse, the custom gesture parser that I created. You're parsing the XML files for each of the template gestures, and after it's successfully done, then you're actually setting it into the recognizer. And after that, you start classifying each of the available candidate inputs or gestures that were provided by candidates from last semester, and it starts classifying those gestures and outputting the result. So that is that. Then if we open, let's close this solution, and if we open again, now we open the Scratchpad C++, which is a better explanation of the overall implementation of the solution, of the API, CircGR API solution. So here we have an extra folder, which is Scratchpad. This particular folder contains the C++ code for the application that is actually utilizing the CircGR API and demonstrates how to actually implement the API. If we run this, what we're going to get is we're going to get a white screen, white console per se, which is the Scratchpad, and it's a touch sensitive window that can be utilized with a touch sensitive device. And we are also going to get a console that will be outputting the results for that window. So let's split this here so we can see this better. We're going to get these two screens. Basically, on this white screen, you can actually touch the window, and what will happen is the fingers will be determined and detected based on touch down, touch up, and touch move events, and colors will actually recognize the different fingers, black being the main finger, and then subsequently other different colors will be rotated for different fingers. What you see here in the console, the first few lines is it's basically setting up, as it says, CircGR as a gesture recognizer, and then it's loading the template gestures, A1 through F8, and then it's confirming that it actually successfully set the templates for the recognizer.